Hey guys, welcome back. We'll continue with the book Automate the Boring Stuff with Python, and in this video we are going to cover debugging. You can read the book for free by heading over to automatetheboringstuff.com, or if you prefer a physical copy of the book, there's a link in the description down below. As we write more and more complex programs, it's quite likely that we are sometimes going to introduce some bugs. And then of course we need to figure out how we can resolve and fix those bugs. There are a number of different techniques that we are going to look at. First of all, we can work with logging and also assertions. And then we're also going to take a look at how we can work with a debugger. Python raises an exception whenever it tries to execute invalid code. We already saw in one of the previous videos that we can work with a try except statement to cover cases in which an exception would be raised, but we can also raise our own exceptions. And to have a look at an example, let's head over to our code editor. So here I'm using the Mu editor. Let's open the REPL and we're going to have a look at how we can raise an exception. So we always use the raise keyword in order to raise an exception, and then we call the exception function, and as an argument we pass the error message we want to display to the exception function. So as we run that, we can see we get back our exception and the error message we provided, and we also get the notification back where that exception was raised. So here we only have one line, so that's being returned. So this is how we can raise an exception purposely without a try except block. In most cases, however, we would be working with a try except statement in the context of a program. And let's take a look at an example here. So here we have a function called boxprint that takes 3 arguments, a symbol, a width and a height. And this function is going to print out a certain pattern by multiplying the symbol here that's provided with the width. And then we are basically adding white spaces around it, and we are creating a box with a certain character. There are certain conditions that need to be met. So for instance, this symbol can only be a single character. Therefore we are checking for the length of the character here, and if it's not equal to 1, then we raise an exception with a helpful error message so that the symbol must be a single character string. We are also checking if the width is less than or equal to 2, and then we raise another exception, and we are also checking for the height that's provided. We're then trying to call our boxprint function down here with 4 different sets of arguments. And if none of these if clauses here are met, no exceptions are raised, then of course we are just executing our function. Otherwise we are going to raise an exception and print out the error message. So let's run our program here, and we can see the first 2 inputs are properly displayed. We just have a look at the arguments again. We can see that we provide a star here and then we provide an O, and this is being printed out as a box. In the third case here, however, we provide a width of just 1, which is less than 3, and therefore it's invalid. And here we see that the width must be greater than 2. And then in the third case here, we are actually providing a symbol with 2 characters, and therefore we encounter this other exception. So this is an example of how we can use that in a try except statement by using our own exceptions. Now when Python encounters an error, it not just displays the error itself, but it also produces a traceback. And a traceback shows us basically where the error occurred, stating the line number that caused the error, and then also the sequence of the function calls that led to the error. And this sequence of calls is called the call stack. So let's have a look at a quick example. Here we are defining a function spam, which calls another function called bacon, and bacon just raises an exception. So here we are showing the message, this is the error message. Then we call the spam function, and now if we run our code, we can see our traceback displayed here, and we can see the first error that's encountered is in line number 7, because here we're calling the spam function, and this is where we first encounter the error. Now the spam function, of course, is defined up here. So as we call spam, we can see inside of the spam function we call bacon. So this is basically the second level where we have the error. So here in line number 2, we can see that we see the error here. And then of course, inside of the bacon function, we actually raise the exception. So this is the origin sort of our error message. This is in line 5, so this is the final line that we get, and here we print out this is the error message. And this call stack can really help us to determine where the error is. So in our case here, we figured out that in line 5, we raise this exception here. Now this was on purpose, but of course, in an actual program, this would typically be unintentional. And then we can use a traceback to go through the call stack to figure out where we made a mistake. We can adjust that and then our program runs properly. Now Python displays the traceback whenever a raised exception goes unhandled, meaning that we didn't have a try except clause. But rather than just showing it to us, we can also get the traceback as a string and then, for example, print it to a file. And for that, let's have a look at an example. So here we are importing the traceback module, and then we have a try except clause. In the try clause, we are raising an exception. This is the error message. And then in the except clause here, we are creating a new text file called error info. And then we are using the call traceback format execution, which gives us back the traceback as a string. We are writing that to our error file here, and then we are closing it. And then we just print out a message that it was written properly. And as we run this code here, of course, we're going to encounter that exception. So we are going to jump over to the except statement, and this text file should be generated. So let's run the program, and we can see the traceback info was written to the text file. Let's have a look at it. And here we have that text file error info, which gives us back the traceback. And here again, we can see in line 4, we encountered the exception, which is of course correct. So whenever we need to further process the traceback, we need it printed out, then we can go ahead and use this traceback.format execution call. In addition to using try except statements and raise statements as we have done so far, we can work with assertions. And an assertion is a sanity check to make sure our code isn't doing something obviously wrong. So we would typically use assert statements to figure out if we made an error programming our code, but an end user should never see an assertion error. And the assert statement consists of the following. We have an assert keyword, then we have a condition that we are checking for, and then optionally we can also add a comma and a string to display when the condition is false. Let's have a look at an example. Here we have a list of ages, and then we are calling sort on that, so we are sorting it in ascending order. And then we are asserting that the first value inside of our ages list, which is now sorted, is less than or equal to the last value, which of course will be true because we are sorting it in ascending order. That means if we run our program now, we don't get an assertion back, actually nothing is going to be displayed. But let's say we make a small modification, and here we are reversing the order of ages. Now if we run our program again, of course this won't be true anymore. So therefore we are going to see an assertion error on line number 5. And so we can quickly have a sanity check whether our code works properly or not. And unlike exceptions, our code should not handle assert statements with a try and except block. If an assert fails, then our program should definitely crash. And it's important to note that we shouldn't use assert statements in place of raising exceptions, because it's actually possible with a small change to the syntax when running a program to run it without assertions. So assertions are really intended during the development phase of a program to be used by a programmer to have a look if there are some errors in the code and to address those quickly. Let's take a look at a larger example. Let's assume we are writing a program to simulate traffic, and as part of that we are having a look at different traffic lights. So here we are taking a look at 2 separate intersections. The first one is between Market Street and 2nd Street, and here we have a traffic light in the north-south direction and one in the east-west direction. Let's assume the first one is green and the other one is red currently, and we have a second intersection between Mission Street and 16th Street, which is currently red in the north-south direction and green in the east-west direction. And then we have a function to switch the traffic lights, and this one changes the value from green to yellow, from yellow to red, and from red to green. And to check whether that's working properly, we are using an assert statement here to check whether red is in the stoplight values, because in order to avoid a collision, of course we need to be sure that one of those traffic lights on an intersection is actually red, so that cars don't collide. So we are asserting that red is in the stoplight values, and if that's not the case, we are going to print out neither light is red and then give back a string value of the stoplight. And we're calling our function and passing in the intersection for Market Street and 2nd Street. And as we run our program, we can see we get an assertion error here because neither light is red. And that's of course when we have a value of green here and we call our switch light function, that's going to be changed to yellow. and the red light is going to be changed to green. So at this point in time, neither one of those traffic lights is red. So that of course would be incorrect. So we would need to adjust our program to ensure that one of those traffic lights is always red to avoid collisions. And especially if we are using this code as part of a much larger program, which maybe has thousands of lines of code and simulates complex traffic, then it can be quite difficult to find the reason for the error. And for that, assertions can be very helpful. So we can add them in there to validate that our program works properly. And by adding these assert statements, our programs fail pretty early, and so we can save ourselves a lot of debugging effort later on because we already tested if that part of the code worked properly. Now, if you have ever used a print statement in your code to output some variable's code while the program is running, you've already been using a form of logging. Logging is a really great way to understand what's going on while your program is running, and Python provides a logging module that we can use in order to easily log what's going on. And to work with that logging module, all we need to do is to import logging at the beginning of our program, and then to add this line here so that we set the basic configuration for logging. And then, for example, we can call logging debug with some information to basically get some debug information while our program is running. So in this case here, we have a factorial function and there's something wrong with it. We want to figure out what's wrong with it, and therefore we are using logging. So in this case here, inside of the factorial function, we are using logging.debug to print out what the value of I is, which is of course a variable here we are using inside of our for loop. So let's run our program and let's have a look at the output. And here we can see at the beginning we are printing out the start of the program at the very beginning using logging.debug. Then the start of the factorial function we are calling factorial with the value of 5. And then we are having a look at the value of I as we are looping through the range from 0 all the way up to n+1, so in our case 0 up to 6. And we can see that the value of I is 0 and the total is 0. So it's always 0, which of course is wrong. If you want to get the factorial of a number, of course we want to multiply the number 1 with every increment of that number all the way up to and including the number itself. So 1 times, 2 times, 3 times, 4 times 5 in this case, but we always get back 0. And debugging helps us to actually find the error that's going on here. So we can see it's always 0, and the reason for that in this case here, as we are starting from a value of 0 by calling the range function. So if we do a small modification and we start from 1 all the way up to n+1, then it should be working properly. So as we run our program again, we can now see that the total value is properly increased. Now this approach may look quite similar to what we could also achieve by just using print statements, but we should generally not use print statements, but instead use that logging capability, because print statements need to be removed manually afterwards, and it's quite easy to miss one of the print statements or maybe to accidentally remove a print statement that we didn't want to remove. Logging is a lot better suited for that, and the great thing is that also later on as we publish our code, we can adjust the logging level and, for example, just log errors as opposed to other debug information. To make it a little bit clearer, let's have a look at the separate logging levels available. There are actually 5 different levels, starting from debug, which we saw before by calling logging.debug. So this is the lowest level. It's used for really small details, and you would typically only use it when you try to reproduce a bug and diagnose the problem. Then one level up, we have info, then we have warnings, and then we have errors, and we have critical errors. And whatever logging level we set, we will get logs from that level and all the way up to the highest level. So for instance, if we set the debug level here, we will also get debug messages on the info, warning, error, and critical level. On the other side, if we set the error level, we will only get error messages and critical messages. So typically in production, we would change the logging level to error, so we only get error messages and critical messages. But when we are developing and we try to debug some issues, we would set it to, for instance, debug to really get all the logs. So let's have a look at those logging levels in action. We can use our REPL to, again, importing the logging module and then specifying this required line here. And after that, we can say that we want to have a look at the debug level. So as we saw before in the factorial program, we again call logging.debug, and then pass the debug message to it. And we can see the debug point here, so we can see indeed this is on the debug level. On the other hand, if we want to log an error, we can use logging.error and then print out the message, so an error has occurred, and here this is an error, of course. And another big advantage that logging has over using print messages is that we can very easily deactivate logging, and when we deactivate logging, we would pass a log level to it, and that means any log with that log level or lower will no longer be displayed. So here we have our logging module, we have again our setup here, and we are logging a critical message. Let's say we want to disable that. In this case, we are saying we want to disable all the logs from critical and lower. And since critical, of course, is the highest of our 5 logging levels, that means all the log messages will be disabled. So if we now, for instance, add another critical log, we can see that this no longer prints out the log message, and that's of course because we disabled the logging. So that's very handy. At the end, we don't have to go through our program and remove all those logs by hand, but instead we can just go ahead and disable the logging level and then decide to only, for instance, display logs that are of the error level or higher, or we could even disable all the logs. Now, instead of displaying the log messages to the screen, we can also write them to a text file. We would use the logging basic config function, and we pass a file name to it under which we want to save the logs. Then we provide the log level and the format in which we want to display this. And now if we run our program, this prints the logs to the text file. Now when we use a Mu code editor, we can also use a debugger to have a closer look at our program and basically go through our program one step at a time. You can find the debug option here on top, and if we click on that, we can see we have a debug inspector on the right side, and then we have the program itself here at the bottom that displays the different steps. And then we have the option to continue, which will cause the program to execute normally until it terminates or reaches a breakpoint, which we're going to take a look at in a bit. Then we can step in, which will cause the debugger to execute the next line of code and then pause again. We can step over, which will execute the next line, similar to step in. But if there's a function call, then the function will be executed at full speed, and we continue to the step after that. And then we have step out, which will cause the debugger to execute the lines of code at full speed until it returns from the current function. And if you want to stop the execution early, there's also a stop button here. So let's have a look at an example program. We have here a program that adds numbers, but it has a bug. So let's first run our program normally, and let's provide 3 numbers. Let's say 1, 2, and 3. And it's supposed to give us back the sum, but we can see there's something wrong, so we don't get the correct sum displayed. So let's now have a look at the program using our debugger. So we click on debug, and we can see we are in the first line here, and of course we stop execution. So let's first say step over, because we want to step over the print function here. So it's now asking us to enter the first number, which is the number 1. Let's type in step over again. Now we're in the print call. We press step over, we need to add the second value here and press enter. And we keep on doing this, enter the third value. And we are at the end of the program. Now if you take a look at the debug inspector, we can see that those 3 values here are displayed, but they're displayed as strings. So we have the string 1, the string 2, and the string 3. And that of course is the error that we get. We actually are not adding those integer numbers together, but instead we are accidentally doing string concatenation, and that's where we get back the number 1, 2, 3. And the debugger really helps us to go through the program step by step to see what the values are, and then to figure out what the actual problem is. Now when we work with a debugger, we may have a program that has a lot of steps, so it would take us a very long time to actually go step by step through the program. And for that we can use a breakpoint, and a breakpoint allows us to execute a program up to a certain point, and then to have a closer look at that starting from there. So let's say for example we have a coin flip program, and here we are flipping coins 1,000 times. And here we are checking if we flipped it 500 times, and then we print out halfway done. Now if we want to add a breakpoint, we want to start execution from there, we can simply click here on the left side, and this is going to add such a red dot, and that's a breakpoint. Now once we added the breakpoint here, we can again start our debugger, And now we can see that rather than having to start all the way from the beginning, we are basically starting at the breakpoint here. So we are saving a lot of time, and then of course we can still go ahead and basically continue with the execution here, but we are starting basically from the middle, so breakpoints can be really useful to start from a specific point or to start from the beginning and then stop executing at that breakpoint that has been set. Let's have a look at the practice questions. And the first one is to write an assert statement that triggers an assertion error if the variable spam is an integer less than 10. Now if we head over to our Mu code editor, we can see we use the assert keyword, then our condition, so we are checking that spam is greater than or equal to 10. And if that's not the case, we are going to add the comma and then the error message, so the spam variable is less than 10. Write an assert statement that triggers an assertion error if the variable x and bacon contain strings that are the same as each other, even if their cases are different. That is, hello and hello are considered the same, and goodbye and goodbye here capitalized are also considered the same. So for that we can use the lower method, and here we are asserting that x.lower is not equal to bacon.lower, and if that's not the case, then we are printing out the x and bacon variables are the same. Next we should write an assert statement that always triggers an assertion error. So for that we can simply write assert false, because that of course will always be false, and therefore we're printing out this message here, this assertion always triggers. What are the two lines that our program must have in order to be able to call logging.debug? So we saw before, when working with the logging module, we of course need to import it first, and then we need to call logging.basicconfig, specify the logging level and also the format in which the logs should be displayed. What are the two lines that our program must have in order to have logging.debug send a logging message to a file named programlog.txt? So again, we need to import the logging module, and then we are working with logging.basicconfig, but now we pass the file name as an argument, and we specify programlog.txt. We specify the logging level and of course the format in which we want to display those logs. What are the 5 logging levels? So we have the debug, info, warning, error and critical logging levels, whereas debug is the most low level logging level and critical is the highest logging level. What line of code can you add to disable all logging messages in your program? So for that we can simply type logging.disable and then specify the logging level. If you want to disable all logging levels, then we would specify the highest one, so critical. So here we're passing logging to critical to that function call. Why is using logging messages better than using print statements to display the same message? So there are a couple of reasons for that. First of all, we can disable logging messages very easily without actually having to remove those logging calls. Instead, we can just specify that we don't want to display those messages anymore. We can also control which level of logging we still want to display. For example, maybe we want to display the critical logging level but not the lower levels. And also logging messages can provide a timestamp when they're executed. And of course, we can also print it to a file if we later on need to export it, for example. What are the differences between the step over, step in and step out buttons in the debugger? So the step in button is going to move the debugger into a function call. The step over button on the other side is going to basically execute the function call without stepping into it. So it's basically going to skip the function call itself. And the step out button will quickly execute the code inside of a function and then step out of it. After you click continue inside of the debugger, when will the debugger stop? So the debugger will stop when it reaches a breakpoint, or if there's no breakpoint, when it reaches the end of the program. What is a breakpoint? So a breakpoint is a setting where we cause the debugger to stop execution. So it's going to start from the beginning until it reaches a breakpoint, and then of course we can decide to go step by step. But it saves us a lot of time because we don't have to start from the very beginning, but we can basically skip right to the breakpoint. How do you set a breakpoint on a line of code in the Mu code editor? So to add a breakpoint, we can just click on the left side of any line of code. This is going to add this red bubble, and that means we added a breakpoint there. So in this video, we covered how we can work with assertions, exceptions, logging, and also how we can work with a debugger to find bugs in our program and debug our code. And that's very powerful because as we write more and more complex programs, there of course are always going to be some bugs introduced. In the next video, we are going to cover web scraping and having a look at how we can retrieve data from the internet. If you haven't already, feel free to subscribe to the channel and see you guys in the next video.